Hi, welcome to the part 8 of this playlist. So, I have posted part 6 and 7 in the members area. Which members area? Cloud Ninja, not Cloud Kernel. Cloud Ninja because it is for advanced certifications. Okay, so you have to take that membership. So, a lot of paid contents will be put there. If you have not yet subscribed, do so. So many people have cleared certifications. So let us look at this question. Here, there is a development manager and they are building a new application. Okay, and then he asks to review his requirements and identify what cloud technologies he can use to meet them. Okay, so what are his requirements? Boss, what are his requirements? These 1 to 6, these are the requirements. So first it is saying that I want open source technology. Then he's saying that the compute should auto scale. If the load is high, compute should go up. If the load is low, compute should come down. It should be elastic. It should support continuous delivery. Okay, that means some sort of CI/CD pipeline software I have to maintain. Okay, so if I just see these three, now what is happening is all four options we see Kubernetes, 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 Kubernetes. See, Kubernetes engine, if you see, you get auto scaling. That is one of the requirements that you have, and it uses GitHub, GitOps based configuration. So your CI/CD is also taken care of to some extent, not fully. You still need a product. Okay. So Kubernetes, we know we want, that is for sure. But then the problem is all four options have Kubernetes, so I am not able to choose which one is correct. Now, if I look at other options, see, since we are talking about this stuff here, I need CI/CD, so I need something like Jenkins. I see Jenkins, two options. What is Jenkins? So it builds continuous integration, okay, for GCP. So I know this is wrong because it does not have any continuous software delivery provision. Cloud load balancing is just a load balancer. So we put this in front of compute. Suppose I have 5 compute engines, I will put this in front of that so that load balancer will decide which compute engine is free and can take more work. Load balancer is like your team lead. If you are working in Infosys, TCS, any of these vendors or software Indian IT firms, so they have a very strong hierarchy of project manager, team lead, and etc. And when people progress from developer to team lead, they become very happy. So some people also act as if they now own developers as, that is how they behave sometimes. Okay, so team lead, what they do, they see which developer is free, which developer has 50% bandwidth, 40% bandwidth to pick this new work that is coming. That is how they allocate work. Okay, so as a developer, what happens? So in this case, as a developer, if you do more work, a faster work, then you will get more work. If you do more things fast, because team lead will just say, okay, this guy is now free, let us allocate some more work. So that is load balancing. And then if we talk about deployment manager, so deployment manager is an infrastructure deployment service. You can automate creation of resources. You can create 3 4 computes automatically. You can have a template written to configure some files, and it works with variety of services like cloud storage, compute engine, SQL databases, but it is not a CI/CD pipeline, so this will not fit the bill. Now we have to choose between A and D. Now, if we see at other requirements, you want segregated copies of same application stack. You want to deploy application bundles using dynamic templates. Okay, and then you want to route traffic to specific services based on URL. So see, if you consider Helm will help you with deployment. So this stuff, requirement 5, deployment, it will help you with that. Okay, and then requirement 6, route network traffic. So this routing of the traffic based on URLs, so that Helm can manage. It is an open source package manager. So that is why our answer would be option A, because Helm will fulfill these requirements also. Okay, and run multiple segregated copies that Kubernetes will take care of. So option requirement 4 will be taken care of by Kubernetes engine. So cloud load balancing we do not need. See, we are talking about routing and not load balancing. Routing and load balancing are different thing. So option D is wrong. And this is our final answer. Option A, Google, Kubernetes, Jenkins, and Helm. See, you have, this is the next question we are looking at. The next question is around compute engine. So you have virtual machines. You have used GCP compute engine, and you have created several compute engines. Okay, you have several virtual machines like this, several of them. Now you want to properly shut down your application before virtual machines are preempted. What is preempted? Preempted can be, it is taken away from you because someone else has higher priority. For example, if you are on the road and a VIP is getting escorted, so that portion will be taken away. You will have to wait for the VIP to clear the route. I mean, they will pass first. They have more priority over you. It is just awesome that every day in different walks of life, you get a feeling that you are not important, almost like you are invisible. So option A says that create a shutdown script and keep it in this path. So it is incomplete, right? What after that? Just creating a script and keeping it somewhere will not help. B says, see why it will not help, because you have to use it somewhere next time, no? Just keeping it, how will it help it? So option B says you create a shutdown script registered as this in Linux, okay, and configure Stackdriver endpoint. Check to call the service. See, Stackdriver endpoint, what is the purpose? To monitor. The purpose is to monitor, like police, your cops. Their purpose is to monitor and do threat detection. If if you tell them, boss, you go and fetch the gas cylinder for your boss, that is not that person's job. But in India, people do it. So in India, what happens is, especially Bihar. Okay, so I still hear they have to be like, they have to be available for their boss for different activities also. Okay, but then not sure of the recent times. So what the point is, Stackdriver is a um, monitoring and logging service. Okay. Option C says that you create a shutdown script and use it as a new data. See, this is awesome, right? You create the script and you use it so that next time when you create a new virtual machine, this script is used. This is my answer. This is the right answer. Now, D says, let us create a shutdown script and use compute instances add metadata to specify the service URL as a value for the metadata entry with key shutdown script URL. See, you can do it without that URL path itself. The service URL, it's not required. You can put the shutdown script directly. So option C is our answer in this case. See, when you do that, you also need, this is what is the important operating system, purpose of the script, trigger mechanism. These details you have to supply as the new metadata. So we have the next question here. Your organization has a 3-tier web application. 3-tier means you have a front end, you have a middle application, and then you have a database. At least in my time, this was called 3-tier. And you want this to be deployed in the same network on GCP. Each tier, whether it is web means front end, API means this middle tier, and database is this one. It scales independently. Okay, each tier scales independently. It is not that if I want to increase capacity, scale up, so all three has to be scaled up in one go. No, independently of others. Network traffic should flow through this guy, through web to API tier, and from API tier to database tier. Traffic should not flow between web and database tier. That means from here it should not flow directly to here. Why? If it happens, why? If it flows directly, if there is that path available, then the SQL injection attacks can happen, and even God cannot save you if that happens. So you have to be careful. How should you configure the network? Add each tier to different subnetwork. See, different subnetworks, dividing this into different network will not solve, because see, they have to talk to each other via this guy. But if this will not solve it if you put on 3 different subnetworks. If you do that, it will increase complexity. It will add performance overhead. So your performance of application will go down, because now additional hops between subnets will happen, which will introduce latency in communication. Okay, and cost considerations. Obviously, if you do that, additional fees will be incurred for what? For inter subnet communication. Okay, or VPC egress traffic. So that means this option will also be costlier. So now second option B, they are telling us, hey guys, let's have 3 VMs and let's have firewalls on individual VMs. Okay, so this is also a problem, because now this will also come with some, see, the solution will be more secure, no doubt, but it will increase your complexity, reduce your performance, and there is a chance of misconfiguration. Improperly configured firewalls can block legitimate traffic or create security vulnerabilities. Okay, see, adding tags and setting up fire rules is the right answer, and this is how it will help. It will simplify the management, it will introduce dynamic policy enforcement, help you with that, and it will help you with centralizing the configuration piece. You can pause it and read this carefully. I have put the reason why this will be helpful. So our final answer would be option D, add tags to each tier and set up firewall rules to allow desired traffic flow. So the firewall rules will ensure that this interaction does not happen directly, because the rules will forbid that interaction. And this option helps you with dynamically creating firewall rules. For example, you can allow all communication between the web and application tiers, but restrict any access from the database tiers. So this ifs and buts of kind of a rule, you can do it. It provides you flexibility, and adaptable security posture can be achieved. Okay, so this brings us to the end of this part. I hope you have already subscribed. If not, a lot of people are gaining benefit out of it. There are so many playlists which different cloud certification contents, and please remember to focus on the concepts explained. So with in this part I went through 3 questions, and what we did is each question had 4 options, 4 topics, so around 12 topics is what we are discussing, and it is just like a training material for you guys. So treat it as a training material. Through questions we are getting trained in the process. Now the paid content is available only for Cloud Ninja members. You need to buy Cloud Ninja membership for paid contents around this certification. This certification is an advanced certification, professional certification. All advanced and professional certification paid content can be found uh, if you take Cloud Ninja membership. So this brings us to the end of part 8. Parts 6 and 7 has been put in the paid area. Please access it.